Okay, welcome. So we're gonna do a practice problem today. We are going to do the following. Um, the telephone manufacturer has calculated that the average life of a phone is 72 months. That sounds an awful lot like mu. 72 months. With a standard deviation of 12 months. How do I know that this is a mu and not an x bar? I know this is a mu because the average life of the phone is 12 months. It was it was manufactured, it was born this way, right? Born this way. It was born this way. This is the manufacturer's settings. When we look at all the phones manufactured by this particular guy or girl or company, then we know that that's what it's supposed to be. Every phone is supposed to be 72 months and 12 months. The manufacturer is considering a new supplier that may increase the life of the product. That sounds an awful lot like a pending hypothesis. We're probably going to end up testing whether or not we should use the new battery. The manufacturer used a microchip in 200 phones. That sounds like N. N is equal to 200, which means we probably have a sample coming, right? Which resulted in a product life of 78 hours. There's my X bar. If I have a sample, then the sample mean is 78 hours, or months. That's supposed to be months. Months. All right, so I'm going to test whether this guy and this guy are the same, probably, or different, or greater than. Test the hypothesis. Oh, they're real nice to you. Test the hypothesis that using the new battery will extend the phone life at 0.1 alpha. All right, so first thing, when in doubt, alpha is equal to 0.01. When in doubt, draw it out. So what am I supposed to be doing here? I am supposed to, I've got this normal distribution. The average hours is 72. 78 is over here somewhere. Not exactly sure where yet, so I'm not really gonna spend a lot of time on that, but it's over here somewhere. And I'm gonna have this drawing where 0.01 is in the right tail, and this is a greater than, right? So something is the new battery, greater than, better than, right? And so I'm probably going to have this thing out here where I'm going to reject the null over here on the right hand side and fail to reject, right? Fail to reject over here on the left. This is a one-tail test, or it looks like a one-tail test. But before we get into the weeds on this, let's go look at our order. Let's go look at our list. Let me put it on the left-hand side. So the first thing we want to do is we want to test the hypothesis in English. So number one, hypothesis in English. H sub 0, H sub 1. My hypothesis is that the new battery will extend life of the phone. And the opposite is new battery will not extend life of the phone, right? Okay, great. Number two, select a statistic. We're going to do mu because this is the average life of the phone. Number three, is this one-sided or two-sided? Well, will extend is greater than, right? So this is going to be a one-sided test. This is going to be a one-sided test. And number four is hypothesis in math. Hypothesis in math. So what is my hypothesis? H sub 1 means that mu is greater than, what's the average? 72. So mine has to be bigger than that one. And this is the opposite. What is the opposite of greater than? Mu is less than 72. Does that seem right? It's missing something. It's missing the equal sign. And the equal sign is always on the null hypothesis. Excellent. 5 is alpha. Alpha is easy. Alpha is equal to 0.01. It is given in this particular practice problem. And then we go on to number 6. Select the test statistic. Number 6. Oh, I'm going to run out of space here. Let me go this way. 6. My test stat is going to be, well, is this going to be a Z or a T? Well, I have n is greater than 30. Is it? Where's my samples? N is greater than 30. Yes. Do I know? So that's good. Do I know sigma? Yes. So that's good. This is going to be a Z stat. Okay, so that's 6. All right. Number 7. Number 7 is determine the critical value. Critical value. Sometimes students get to the critical value and they're like, well, I don't know what to do next. So we go back to our mantra. When in doubt, draw it out. When in doubt, draw it out. So let's draw this out. We have our curve. We have our normal distribution. Here's our deal. How do I figure critical value? Critical value is based off of alpha. Alpha is over here. Because this is one-sided, the entire thing goes onto the right tail. There is nothing to split with over here. All right, there is no left tail on this one. So that's 0.01, which means this is 0.99, and I'm looking for this guy right here. This is my critical value, right? That's my critical value. So we could go to the tables and try to figure out what Z is here or what Z should be. But we also know that on one-sided tests, there are some very, very common alphas. Alpha at 0.01, alpha at 0.05, alpha at 0.10. And these are just known. You could go back and you can calculate them. It's nothing more than finding out, the right tail or the left tail inside your Z table. Remember your Z tables, 9, 8, 7, 1.9, 2.0, 2.1, and so on. And then you figure out, this says 0.9901 or something, and you figure out that this one goes to that one, so you select whatever it is that you select, which you can do, which is fine, and you should have that skill already developed from Stats 1, but there are one-sided alphas that we know that we're going to use a lot, and you should have these memorized, if not written down. And for alpha 0.01, it's 0.33 for a one-sided test. For 0.05 is 1.645. For 0.10 is 1.28, and you're just going to see these a lot. So my critical value in this case is going to be 2.33. So Z here is going to be 2.33. Right? So Z sub, technically this is like Z.99 or Z point whatever, Z.01, Z.01, depending on how you're looking at it, is equal to 2.33. So I know that if my calculated stat is greater than 2.33, then I'm going to reject the null hypothesis. And if I'm on the left-hand side, I am going to fail to reject, right? So then what comes next? That's number 8. Let's go to number 9. Let's zoom out just a little bit. Let's go to number 9. Number 9 is calculate the stat. Nope, sorry, that's number 8. Number 8 is calculate the stat. Well, a Z calculation is relatively simple for us. This is going to be x minus mu over sigma. It's a classic Z calculation, but we're not dealing with an x, right? We're not dealing with a single observation. We're not dealing with a single observation. We're dealing with an x bar, which is the mean of all the single observations, or the sample mean. So what do we have to do? We have to convert this guy to an x bar, and then we have to make a modification in the denominator to divide by the square root of n, right? Relatively simple, but it's got to be done. So now at this point it's plug and play, and one of the things I like to do is I like to come back to my I like to come back to my variable list. Maybe I should have typed these out. Oh, can I get the just without the arrow? Oh, that'd be so cool. It is. Copy. And let me come down to my plug and play, calculate stat, and I'm going to paste. Ta-da! So there's my plug and play. So let's do this. Z is equal to X bar. What is my X bar? X bar is 78 minus mu is 72 divided by sigma. Sigma is 12, and that has to be modified by the square root of n, or the square root of the sample size, which is 200, right? Now I'll save you some calculations. You can pause here for a second so you can practice calculating, and you should, but Z is going to be 7.07, right, after you do all of these calculations. Pretty please, my dear Aunt Sally applies, obviously. And then, you know, just keep that one in mind. I think you already know where we're headed, but let's go to number 9, make the decision. And here, if you don't know what's next, is another great paint to draw it out. So number 9 is make decision. You should always draw this out until you are super, super confident, and that doesn't happen until you're in grad school. Make the decision. When in doubt, draw it out. So let's draw it out. Here is our normal distribution. It's actually modified because we have an X bar. I know that over here on the right-hand side, we have 0.01. My critical value Z here is 2.33. 2.33. I have 99% under the curve on the left-hand side. My Z-stat is equal to 7.07, which is way over here somewhere, right? 7.07. And I know that if I am on the right-hand side, I'm going to reject the null hypothesis. And over here, I'm going to fail. Let me do a different color. I'm going to fail to reject the null hypothesis, right? So in this case, because I'm 707 and I'm on the right-hand side of this line, then I am effectively going to make the decision that we will fail to reject. And then I go to finally number 10, state the conclusion. Conclusion. And my conclusion is the new battery will extend the life of the product. And you've got all these ideas in your head if you're a marketing guy that you can come in the room and you can make the sale. But a sophisticated company is going to run a sophisticated company is going to turn around and say, hey, does your product work? I don't know what it's, you know, what alpha did you run your results at? Oh, we ran our alphas at 0.01, and we have found definitively with, you know, that at an alpha of 0.01, this extends our battery life by about three months or 3 hours or whatever it is, 3 months of life. And so that's how we make business decisions. We don't make business decisions because somebody walks in the room and says, hey, you're amazing. We make business decisions because we are going to reject the null after doing some serious statistical processes. There's a lot to cover in here. When in doubt, draw it out. But maybe most importantly, don't forget to go back to your list of 10. And so just check these off one by one as you're getting them, as you're doing them, you know, just check them off. And then you get down to the bottom. And every time you have a problem or you have a doubt, you know, make sure you stop and draw it out. Good luck.